Okay, here's a past HSC question, very similar to the one that we've just done. The numbers look pretty similar too. This time though, they've told us what the x and the y components of the initial velocity of some object that gets released and goes from point A to point B again on a horizontal surface. So let's see if we can look at this one. Well, what's the horizontal component of the projectile, the velocity of the projectile when it lands? Well, ux equals vx. In other words, the horizontal component ignoring drag, and we always ignore drag, and this is unchanged. Okay, so let's go and have a look at the two second parts of this. We need to find u. Well, if you remember from before, that we need to break it up into its horizontal and vertical components, or in this case, to recombine the horizontal and vertical components, ux, to find out what u is. Well, we looked at this before. Uy equals u sine theta, where this is theta here, which happens to be an unknown angle, so we need to find the angle as well. Ux equals u cos theta. Okay, so that means that u equals, we can work it out from pretty much any of these, except once we find the angle. So the first thing we need to know is to find the angle, and we can get that very simply from tan theta is going to be equal to uy divided by ux. So that'll give us the angle first. Once we've got the angle, then we can put it back into our sine cos rules to work out what our u is. Okay, so that means that theta equals the arctan of uy divided by ux. Let's grab our handy calculator and have a go at doing this. So our uy is 40. So we want to go arctan of 40 divided by the ux, which is 45, gives us an angle of 41.6 degrees. So that means theta is going to be 41.6 degrees. Okay, so there's our theta angle there. So let's go theta equals 41.6 degrees, and then we can use that into either of these two laws. Doesn't really matter which one that we use. So we can rearrange either of them. Let's use the ux. Pick one, any one, doesn't really matter. Let's use the ux. So if we rearrange that, u equals ux divided by cos theta, which is going to be equal to our ux is 45. Ux is actually 45 divided by the cos of 41.6 degrees. Grab our calculator again and go, okay, so we're talking about 45 divided by the cos 6. That's looking right, which is around about 60.2 meters. 60.2 meters per second. So that means u is 60, roughly 60 meters a second, the minus 1. So there we are, we've done the u part of it. Now the range, let's just do the range. Work through a range calculation once again. So very simply, speed is distance over time, or ux is going to be equal to the change in displacement divided by the time for the total flight of our thing. So what we need to do first of all is to work out what our time of flight is. So let's calculate the time of flight. We can simply do that by working out the time to the top of flight and the time back again. Because this one happens to be symmetrical, we can do that one. So for this one, we're going to do it a simple way like that, which again is using this equation here, v minus u equals gt. We've done this a few times now. G, which is going to be 0 minus 40 divided by minus 9.8. Let's see what that is. So we've got 0 minus 40 divided by 9.8, negative 9.8. That's looking pretty right there. So our time to the top of flight is 4.81, wasn't it? 4.081, sorry about that. 4.081, let's call that around about 4.1 seconds. So if that's the time to the top of flight, then the total flight time is going to be simply twice that. So t equals 8.2 seconds. That's our total time for our flight. And then we're simply going to use this equation here to work it out. So Rx equals uxt, which is simply 45 times 8.2. 45 times 8.2 is 369 metres. Okay, so the range of the projectile will be 369 metres.